How is everybody today? A little hungover, maybe? A little tired? Me too. So today we are talking about Azure. We are talking about Azure Backdoors, how to hide them, how to find them. Anybody using Azure, like attacking Azure, defending it? Okay, a couple of people. Okay, cool. All right, so hopefully some of us will learn something during this talk. This is me. Javi, thank you for the nice introduction. So I think I heard a couple things and understood a couple things Javi said. So I'm a co-creator of a piece of software called Bloodhound. Now my full-time job is I'm product architect of Bloodhound and the commercial version Bloodhound Enterprise. I work at a company called Spectre Ops in the US. And on Twitter, you can find me at _Waldo with a 0. Here's our agenda, little intro, some opening thoughts, how we can hide and find persistent access, and how we can hide and find stealthy privileges, and then a conclusion at the end. There are a lot of links in this deck. There are a lot of references in this deck. So if you look at the bottom, there is a bit.ly link that you can use to pull up on your phone or pull up on your laptop, whatever, and follow along. I recommend that you do that. There's also like a lot of small text that might be kind of hard to read on the screen. So by way of introduction, let's talk about the perception in the offensive security and defensive security world. I think a perception is that a lot of times the red team comes in, they beat the shit out of the blue team, and then the blue team, laments the fact that they're always playing catch up with the red team. They're always trying to catch up, maybe one day stay ahead of the red team. So the blue team, they have their detection engineering, they have their prevention tactics and techniques, they have their tools. Red team's got our TTPs, our tools, and our research. So this is, I think, the perception. Does anybody agree with this? Or does anybody see it this way? I think the reality is actually closer to this. I think the blue team and the red team are, in fact, on the same team. If you think about it, don't we work for the same people? If you're red team at a bank, your employer is the bank, they pay your paycheck. And if you're going against your employer, that's probably not a really great tactic for your career. So I think the reality is that the blue team and the red team are constantly improving each other, like iron sharpens iron. And in fact, it is the red team and the blue team that are constantly playing catch up with the emergent risk that is being created all the time by a combination of software vendors, legacy technologies, new technologies, and common configurations that emerge out of all those things. So we're talking about backdoors. Let's give a little definition to what that means. So during the talk, we'll just agree that this is what a backdoor means. It's any system or mechanism whose legitimate purpose can be subverted to provide long-term illegitimate access. Here's the point of this talk. I want to help us understand how these new services and features, particularly in Azure, can be abused by adversaries to install long-term persistence and maintain stealthy privilege. So let's do that. First, we're going to talk about hiding and finding or hunting for persistent access. The first thing that we're going to look at are some living off the land TTPs. So based on services that are legitimately supposed to be used basically for command and control purposes. And there are many of those services where you can legitimately access an API endpoint and have some kind of compute resource in Azure Resource Manager do a thing, run a command, run a PowerShell script, run a batch script, whatever you like. There are a lot of those. We're going to look at one example with the virtual machine run command API endpoint. Has anybody heard of this? Anybody familiar with this? I see one hand. Okay, cool. In Azure Resource Manager, which is Microsoft's, let's say, infrastructure as a service product, when you create a virtual machine, there will be a virtual machine object that exists in Azure Resource Manager. You can read this and you can interpret it as a JSON object, and there are different features on that object, and there are different endpoints that you can access through that object as well. What you also have is the actual virtual machine, the actual system that's running an operating system like Windows or Linux or whatever. On that virtual machine, there is a process called Windows Azure Guest Agent. This thing has a pretty important job, and the way that it accomplishes that job is every 15 seconds, this process will send a post request to a special public IP address owned by Microsoft that is more or less guaranteed to always be accessible from a virtual machine. So even if your target is doing some kind of like air gapping, or if they are filtering egress traffic or whatever, this IP address is almost guaranteed to be accessible from the virtual machine. That heartbeat includes information about disk space usage, CPU usage, memory utilization. It also includes information about the most recent jobs that have executed on that machine and what the output of that job was. As an attacker from the internet, not having any kind of initial access, given the right privileges, we can submit a run command job to the VM object through the run command API endpoint. That will then create information, not necessarily on the VM, but related to the VM, with some information about that job. So there'll be a job ID, what the command is that you actually want to run, what the result is, the output, and if there was an error. Then through that endpoint, you just pull for output until finally there is some kind of output. The heartbeat mechanism from the virtual machine will pick up this job information from the same source. It will run that job, it will execute. So here we're just running like, who am I? And then it will post back after, like at the next 15-second heartbeat interval, it will post back the result of that job. Was it an error? What was the output, etc. And then as an attacker or as an admin or whoever, you can then read that output. So doesn't this kind of look like command and control by design? Doesn't this look like command and control as a service that is maintained, patched, and has guaranteed uptime from the vendor? Isn't that nice? So if you don't even need to install a malicious agent on the system, why do it in the first place? So you can abuse this legitimate access or this legitimate system. So you can use the Azure Portal GUI to do this. It doesn't have to be fancy. And the way you navigate to this is you go to the VM object, you go to run command, run PowerShell script, and then just type whatever command you want to run. It will run it in a PowerShell run space, but you have access to all the DOS commands there as well. And then if we run like who am I, for example, then the job output will eventually display in the Portal GUI like this. So this is the easy way, and this is the way that, let's say, is a little more user-friendly, but there are also significant drawbacks to relying on this GUI. So the question is, why not just use the GUI? Why go fancy into the details about the API endpoint and understanding how this actually works? What's the point? The point is that you can't always use the Portal GUI. If you're authenticating as a user, then there is a token exchange flow that happens when you access the Portal GUI that gives you all the tokens you need to access everything there, and it works. If you're authenticating as a service principal, which is going to be most likely the case if you are executing an attack path in Azure, you can't use the Azure Portal GUI as a service principal. Your only option is the API endpoint. Your user might also not be allowed to use the Azure portal. And finally, there may be some kind of conditional access or continuing access evaluation that prevents you from accessing the portal from the internet, or even accessing these API endpoints from the internet. And so then you start talking about tunneling your traffic through the target LAN, which you can do that, and you can abuse like the debug protocol in the Chrome browser to hijack like a Chrome session. But that gets really finicky, and that gets really unstable. So doing this through just REST method requests is a lot easier, and you can use a much dumber agent to bend that traffic through the LAN and then back up into Azure. Here's a little example of how this works. So these are all just REST API endpoints. There's nothing fancy here, but I'm just doing this in PowerShell. So first, we do a post request to a particular URI where we submit the run command job. Then, when that's done, we get a URI back from that endpoint that tells us, here's where you need to go to check the status of this job. And then we wait, and we just keep checking that over and over. And then usually, like after 10 to 60 seconds, you can actually get the job output. So here's how we poll for the job. And then when it's actually complete, we can return the job output, and I cut off that screenshot so you can't see what it actually was, but we'll look at this video here and you'll be able to see it. So I'm trying to use this thing. Nice. So there we're getting a token that is scoped for Azure RM. We're targeting a particular virtual machine, and we're telling it we want to run the whoami command. And as you could see in that job output, sorry, I'm getting used to this clicker. As you can see, finally, when the job is done, we get the output, and it's running as NT authority system. So that's the user that process runs as. Honestly, I can't think of a more ideal Trojan or rat. So thank you to our friends at Microsoft for giving us this. Does anybody here work at Microsoft? Anybody want to admit it? Okay, there's a lot more out there to be discovered with legitimate services that can be abused in this way. Microsoft is also making changes to and adding features to this set of products all the time. I think every month there is like a new compute service API that's either coming out or has changed fundamentally. The research that we've done, we've barely scratched the surface of what's out there. There's a talk I did at Insomnia Hack in Geneva that talks through how you can do this kind of research yourself to discover what these services are, how they can be abused, and how to create your own easy POC to prove out that thing actually can be abused and understand it. And then on the SpectreOps blog, we've covered like function apps, logic apps, automation accounts, and some other stuff. So those links are there. Okay. Now let's talk about abusing alternative authentication mechanisms. This is a really fun one because some of this is kind of new. And everything that I've seen so far, I think I've seen one resource out there that has talked about abusing these services. Everything else is just about like how wonderful and magical passwordless authentication is and how it's the future and everybody should be doing it and all that. Well, guess what? As an attacker, we can abuse these legitimate services as well for our own evil purposes. We're going to talk about two of these. We're going to talk about SMS, and we're also going to talk about certificate-based authentication. There are other passwordless authentication mechanisms as well, and these are future research areas for us. FIDO2, Microsoft Authenticator, and something called Temporary Access Pass. First, let's talk about SMS. When you have an Azure Active Directory tenant, there is something called a trust boundary that is established around that tenant. And what that means is that any resource that lives in that tenant, if you own that tenant, you own everything in that trust boundary. What it also means is that by default, that trust boundary remains solid, like a wall around or like a moat, I guess you could say. But we can invite people in across that trust boundary, and we can create trust relationships. Admins do this all the time for legitimate purposes. We can do this for evil purposes, depending on how much privilege we have during our attack path. Is anybody familiar with like on-prem Active Directory? If so, a good analogy would be like an Active Directory domain, or rather a forest. An Active Directory forest establishes a trust boundary. Not a domain, a forest. So in this example, we have a tenant that contains a Azure Active Directory user. And as the attacker, we are going to add a phone number to this user's object as an alternative authentication mechanism. This means that we can authenticate not with a password, but with a phone, with an SMS challenge. What this creates is kind of this limited federated identity trust. So the tenant trusts a phone to be an authentication authority for this particular user. So imagine all the possibilities with adversaries targeting telcos and targeting mobile carrier services and companies. Owning a phone is not that hard. And so there's risk not only from the perspective of an admin doing this legitimately, but also this being planted by an adversary and ignored and never audited and never found. So here's how this works. In this video, we are going to install our backdoor on a user. So we are getting a token that we can use to authenticate to the tenant here. Then we're constructing a JSON body. So we're saying that SMS authentication method configuration, we're going to add the SMS authentication method to that user. And the user is specified here in this part of the object. This is the ID of the user. This is the display name of the user. So there we are enabling the user to actually use SMS-based authentication. Then the next step is we're actually going to add the phone number to that user, which we're doing here. So I filtered out the phone number because it's actually my phone number, and I don't want a bunch of evil hackers to see my phone number. But now, oops, I screwed that up. Let's try this again. Nope. Okay, we're going to wait patiently for the video to catch up. This is why you don't do live demos. Videos are better. Okay. So at that point, the backdoor is installed, and we can go on. So now that the backdoor is installed, we can maintain access to this user. So even if the user changes their password, we are going to be able to log in and authenticate as that user just with the access that we have to a phone that we've implanted on that user. The way you do this to actually use the backdoor is go to the Azure portal or some other kind of Office 365 authentication page. Put in the phone number that you put on the user as the backdoor. And then if you get this prompt, select work thing. It will send you a text message on your phone. And then you put that code into this text box. And then after you do that and hit sign in, you are authenticated. You can do this with the Azure Portal GUI. You can do this with the OAuth token acquisition endpoints, and the token exchange flow is also available to you after that. And so next, we're going to talk about, let's go to the next slide. There we go. So here's everything that we just did, but laid out in text form. So the first step is we enabled SMS authentication for the entire tenant. We activated a license for the target user. We enabled SMS authentication for the target user. And then we added our own attacker-controlled phone number to the target user's authentication methods. In this first step, this is the atomic action that we actually took. And I would say that 99% of the time, this action is going to be performed from an attacker-controlled machine, not a defender-controlled machine. So EDR is not going to help in this circumstance. The privileges that you need here are pretty high. You need a lot of privilege to be able to do this. So you either need this MS-Graph app role called policy.readWrite.authentication method, or you need global admin or the authentication policy administrator role. That's a pretty high level of privilege. there are artifacts created by this step as well. So in the Azure activity logs, there will be a log called authentication methods policy update that if you're a defender, you can start to collect those and you can start to parse those to see if an attacker or if a upset IT admin or whoever is installing some kind of backdoor onto one of your users. We activated a license for the target user. So we do a patch request to that URI. This requires not as much privilege. So a global admin can do this. Global admin can do anything. But also the user administrator role lets you do this. The license administrator role lets you do this. So these roles that are not going to be as well protected, ideally, as the global admin role, can do these malicious actions. This will create an artifact in Azure Active Directory activity log called change user license. The third step, we did a patch to that URI. You need that privilege in order to do that. And it creates that artifact. The fourth step that we did, we actually added the phone number to the user's object. That's a post method to that URI. And the level of privilege that you need here is kind of similar to one before. And it will create that artifact there. Now, what's important to understand is that along that path, we could have started at step 4, or we could have started at step 2. It just depends on what licenses the target user already has. It depends on if SMS authentication is already turned on for the tenant. And it depends on whether the user already has SMS authentication enabled. If those things are already set, then you don't have to go through all those steps. You can just start at the end. You can start at step 4 by just making this one simple request. So this backdoor can be installed with one post request to a particular URI, just depending on how much privilege the attacker has and what configurations already exist. You can find these backdoors using various tools. This is how you can do it with a tool that I created called Bark. And so to do that, you acquire a token for MSGraph as your legitimate audit account, whatever. Doesn't need a whole lot of privilege. Create a user's object in PowerShell by collecting all the users from the tenant. And then just filter by what users have a phone number specified as an alternative authentication method. And so by doing this on a regular basis, maybe, you can find these backdoors as they are created. Next, let's talk about certificate-based authentication. All of this is going to be based on this blog post right here by this super smart guy named Mariusz Sobalkin. So Mariusz did this blog post talking about CBA as a potential backdoor method. I went through the process of actually doing this in a test environment, and I almost pulled my hair out because it is so incredibly hard to actually get right. But yeah, let's see how we do that. There's also a link to his blog post here if you want to see the details that he wrote up. So again, we have this trust boundary, okay? We can have a evil attacker-controlled root certificate authority that exists outside of the purview of the defenders. And we can install that as a trusted certificate authority on the Azure Active Directory tenant. That then becomes a completely federated identity trust where the tenant will totally trust that CA. So then that CA becomes an alternative authority for every user and every service principal in the environment, depending on the configuration. So the first step here is to create a certificate authority. Who here has created their own certificate authority? Few people. Okay, it's not that hard. So you can do this with like OpenSSL. You can do this with ADCS. There are various different ways that you can create your own CA. So in this screenshot, we've already created the CA, and we are printing the CA's certificate. This is the public certificate for this CA. And what we're going to do with that is we are going to upload it to the Azure Active Directory tenant via a particular endpoint. This video is 15 seconds, so I got to be quick on pausing it. All right, so here We get a token for a user that has a privilege to do this. We have a PowerShell variable that we're assigning to the value of the cert. We build this JSON payload to match the expected input that the API expects. And then we post that to this URI right here. The endpoint here is certificate-based auth configuration. And then the output that we get tells us that this has been installed as a root authority on the Azure AD tenant. Then here we are enabling certificate-based authentication, and we're just doing it for all users in the Azure AD tenant. You can configure this like on a per user basis or a per service principal basis. But here we're just saying that it's going to be valid for all users. And we're also saying that the property in the ticket that will identify the user is going to be its user principal name. So this would be like Andy@ekoparty.com. It would be that kind of format. That lets Azure AD know that when it is inspecting that ticket, it knows what to look for to make sure that the ticket is valid for authenticating the target user. Okay. Now that the backdoor is installed, here is how we actually use it. And here we are operating from like an attacker VM, or like our own evil hacker machine. The configuration for OpenSSL needs to look something like that. I'm not going to pause this, but yeah, it needs to look like that, and it took me a long time to figure that out. So we will assign user principal name to our user that we're targeting. We'll create a CSR, and then we need to sign that CSR with the CA. The CA is on this computer, so we just sign it here. Then we create a PFX file, and this is the file that we will actually be using to authenticate as that user. So we'll install that cert in Windows. We'll reload the cert manager MMC, and we can see that cert is there. And you can see that the user principal name is part of the subject alternative names property on the ticket. We'll open the portal GUI in a browser, type out the username that we want to log in as, select the cert that we just created, and now we are logged in. Again, this will persist through password changes. And so it doesn't matter like if the user is changing their password, and depending on configuration, you can also use this to bypass MFA configurations given the right circumstance. That's the video we just watched. So there's only 2 steps to this. First is we added a root CA cert to the Azure AD tenant, and then we enabled cert-based authentication for all users in that tenant. This first step, we do a post to that URI. We need that level of privilege, so it's a pretty high level of privilege. And it will create that artifact in the Azure AD activity log. I say it's a high level of privilege, but to be honest with you, policy.readwrite.authentication method, I would say is probably not as well monitored as it should be, because I don't know that it's understood that that privilege allows you to do something like this. So you may not be able to escalate to global admin, but you can escalate to this privilege, and then you can escalate to global admin by targeting one of them with cert-based authentication. So this can be a way to escalate yourself higher than you would be able to otherwise. Second step is we enabled cert-based auth for all the users. We do a patch to that URI. The privilege is required, so if you're doing this as a service principal and you're doing this with application permissions, the documentation says that this is quote-unquote not supported. I'm not quite sure if that's true, but I need to test exhaustively and see if it actually is true. Otherwise, you need either global admin or authentication policy admin. Again, that second role is not going to be as well protected as global admin. And it will create that artifact when you do that action. Okay, so last persistent access mechanism that we're going to talk about is something that I refer to as implicit trust via OIDC. Again, we're starting off the way we have with the other two. We have an Azure AD trust boundary that is solid, not pierced. And in this Azure AD tenant, within that trust boundary, we have the tenant object and we have a service principal. A service principal is a principal that is able to authenticate to Azure AD. It's able to get tokens, and it's able to do things. Like it can do privileged actions. It can read from privileged endpoints. And so you can think of a service principal as being kind of analogous to a user, kind of. There are differences in how they behave, but just think of it as a user, basically, or like a service account. So here, what we are going to do is we're going to target the service principal specifically by configuring an OIDC connector from an external GitHub repository to this particular service principal. And installing this backdoor, we don't touch the tenant at all. So this one is actually one of my favorites. What that will do is that will create this kind of limited implicit trust from the tenant to this GitHub repo. If you were to look at the tenant object and look at like the alternative authentication mechanisms or look at the security panel, this GitHub repo won't show up anywhere if you're trying to audit for this. It will only show up on the service principal. Azure AD tenants that are around long enough, the number of service principals that exist in a tenant can be in the hundreds or even in the thousands. So auditing for this kind of thing can be very, very hard without automation. Here is how we do this. So in this video, we have already installed the backdoor. I'll show you details on how we did that before. On the GitHub repo, we are going to run this YAML file through a GitHub jobs worker, or whatever it's called, a GitHub actions worker. In this example, at the very bottom there, you can see that it is running the command azad group list. So this repo has this YAML file that doesn't have credentials for the service principal in it. There are no creds for the service principal. The fact that the repo is making the request to the token acquisition endpoint is enough that it can get a token. So we changed that command to export and print the token from the result of this GitHub Actions job. As you can see, this is actually kind of censored out. There are 3 stars there instead of the token. A GitHub Action worker is an ephemeral virtual machine. So you can do anything on that thing. It's just running bash. And so we can evade this obfuscation by introducing our own obfuscation. So we will defeat their mechanism basically with itself. So we will pipe the result of that token acquisition command to base64, and then we will print out the base64 payload in the GitHub action. When that is done, we can see the result, and it's there. So this is the base64 encoded MS graph scoped token for the service principal. We never supplied any credential whatsoever. We don't need the credential when we have an OIDC connector. If we debase64 this, you can see we have the token there. This token is what we use to authenticate to all these different API endpoints. So at this point, we effectively are authenticated to Azure AD as the service principal. We can prove that just very simply by collecting the service principals from the tenant and then selecting the first one, just to prove that we are authenticated to the tenant. This is how we install the backdoor. We get a token, we create a JSON payload, and that was it. That actually went really fast. It's just one simple request. So let's pause this when it finishes. Okay. So as the attacker, we are acquiring a token. We're creating this JSON payload to add the GitHub repository, the GitHub organization, and the branch name to the service principal as an OIDC connection. Then we make that request here, and the output is that it just confirms back to us what we just wrote to it. Some API endpoints will do that, most of them do not. Most of the time you don't get any output from these endpoints. You'll get like a 200 and you know that it was okay. So installing this backdoor is super easy, it is super fast, it is one request, and it is very hard to find by defenders. So, one step. All we did was not that. Nope, that's not what we did. So I need to fix that slide. All we did in step one is we added the OIDC connector information to the service principal. That is the correct URI for what we just did. So we're posting to the federated identity credentials endpoint for an app registration, actually, not the service principal. I can talk more about that if there's a question about that later, but it's really confusing, the relation between those objects. So the level of privilege you need here is much lower than what you need for the other backdoor primitives that we talked about. You either need application.readwrite.all, which admins give out like candy, or you need one of these Azure AD admin roles, like Cloud Application Administrator or Application Administrator. When you start auditing Azure AD tenants or you start attacking them or whatever, you're going to see people have this role all the time and everywhere. Not only users, but also third-party applications ask for these privileges too. So this backdoor is the most accessible, is the simplest to install, and it's the hardest for defenders to find. So this one, that's why I like this one the most. Here's the artifact that's created, a log that says, quote unquote, update application. That's helpful, or not. So you actually have to parse this event log to understand what property was changed, how was it changed, what did it look like before. So detecting this is very hard to do. Preventing it is much easier, I think. Okay, we have 7.5 minutes left, and I think we're doing pretty good on time. So with all of these different backdoor mechanisms that will let us reestablish access after we've been kicked out, or if we just want to log back into it after we haven't been there for a year, whatever, we also want privilege. And there are various ways that we can hide our privilege that have varying degrees of difficulty for the defenders to catch. So I'm only going to talk about one of those methods because it also, just like the backdoor installer that we just saw, this also meets all the criteria for being super easy to install and super hard for defenders to find. And I'm going to explain why that is. If you have ever used Azure Active Directory, you have probably seen this screen. This screen is showing us the Azure Active Directory admin roles that exist in the tenant. And so as an admin, you might use this GUI to audit and let me click on the global admins role and let me see who has that kind of active assignment on that role. And we can audit for this and we can say, all right, does Nate really need to be a global admin? No, absolutely not. Do I need to be a global admin? Yeah, I think so. I think I earned it. So admins will typically use this GUI to do this kind of auditing on a regular basis. But there's a problem. There is a role in Azure Active Directory called Partner Tier 2 Support. And if we read this, it says, do not use. Admins are so good at reading instructions, aren't they? And every kind of best practice, admin is always follow to the letter. There's no reason an admin would ever use this, right? Wrong. So it says, this role has been deprecated and will be removed from Azure AD in the future. I don't know how long that statement has been there, but this role is still there. It's an older one, but it still checks out. Now, the privileges that this role gives you are pretty powerful. You can see some examples here where we have like Microsoft.directory/applications/credentials/update. So that would let us add credentials to an application object and then authenticate as the service principal associated with that application. That's pretty nice. It's even better if the target service principal is like a global admin or something. But there's an even better privilege that this role gives you. And that privilege is Microsoft.directory/role assignments/all properties/all tasks. Anybody guess what this role lets you do? Everything. Everything. This role lets you promote yourself to global admin. So it is not global admin, but it's just as good. Even better if you are trying to hide your level of privilege. Why is that? That's because that role does not show up in the GUI. It's there, and when the page makes the request to build the table showing those roles, that role does come back in the payload, but it doesn't show up in this table. Why is that? I'll tell you. This is a bit of JavaScript that is involved in building this table on this page. And if we zoom in a little bit, we get this little bit of JavaScript right here. There is a list called allow listed role template IDs. And as you can see here, this is evaluating whether the role is a built-in role and whether it is part of this allow listed set of role IDs. If it is built in and it is not in that list, it will not show up in that list. That allow listed role template IDs lives here. So that's fun. And that's the part of the JSON that lists out what those IDs actually are. The partner tier 2 support role is not there. There are several other roles that are not there as well that can be not as dangerous as partner tier 2 support, but dangerous enough that you would want to know about this. So this is what this creates if we have an OIDC connection, which is super sneaky, and then we grant that service principal this partner tier 2 support role, we have a backdoor and a level of privilege that is very hard for admins to find. Without automation, without actually using the API endpoints, or maybe without using a commercial tool, you're not going to be able to find this backdoor, or at least not very easily. So this service principal, if we give it this hidden role called partner tier 2 support, is that 5 minutes left? Okay. That means that that service principal can then promote itself to global admin. Global admin has full control of the tenant. So we have this very, very nice, sneaky backdoor and privilege. Here's how you can audit for this. You want to gather all of the Azure AD admin role assignments. You can do this with Bark. Then you want to filter those role assignments to find role assignments that match the partner tier 2 support ID. And then the result there that you see at the bottom where it says ID, principal ID, directory scope ID, that's telling you that there is a principal whose ID starts with 2C537, et cetera, that has that role. If you find this, this is bad. This is very, very bad. Even if a legitimate admin has done this, they should not do this. They absolutely should not do this. Telling the difference between something that is legitimate and illegitimate, forget it. Just tell them don't do this, force them not to do this. This is a backdoor. Okay, let's have a conclusion. I would say that right now, there has never been a better time to get involved in Azure abuse research. Azure has been around for over 10 years. But the offensive security research in this area is still very new. So remember earlier I talked about how the red team and the blue team, we're still catching up to the vendors, the configurations, and the admins, and the risk that all creates. That's so true in Azure. We are still just playing catch up with even understanding the basic mechanics of how this system actually works. So if you're looking to get into research and you're looking for an area to do that in, I highly recommend that you look at Azure. If you have existing expertise with like databases, DevOps, web apps, whatever, that probably exists in Azure, like in Microsoft's own special flavor. So you can build on your existing expertise to dive into this research and have a pretty easy time of it, I would say. And if you're an expert in databases or you're an expert in DevOps or whatever, you are super well equipped to find interesting attack primitives, abuses, etc. You can see the full, maybe, list of services at that URL. In reality, there are more services than what that page shows. If you're interested in more research, follow these people who work at Microsoft. These are the people who are setting the pace for Microsoft as a vendor. The features that go out, they're talking about them. And so if you want to stay ahead, if you want to catch up, follow these people and see what they're saying. Follow these people on Twitter. They do offensive and defensive security research in Azure and in other platforms. They are super smart. I highly recommend that you follow them. Check out these pages, bookmark those. That one in the middle, AZ Advertiser, is super interesting because it tells you whenever a change was made in Azure, which happens all the time. And I would say thank you very much for your time. And if you have questions, I think we do have time for questions. No, we don't. Yeah, so questions, I think what Javi is saying, like, I'm going to go outside, and if you have questions, you can ask me there. Also, if you want to follow me on Twitter, that's my handle is @_Waldo, and I've got stickers with me, so if you want a sticker, come get a sticker. Thank you.